Welcome back to our channel GIS Resources. Ever seen a drone survey a landscape and wondered how those tiny images turn into large, accurate maps? It all comes down to how the images overlap. A simple concept that's absolutely critical in photogrammetry. We're exploring a topic that can make or break your mapping project. The types of imagery overlaps in photogrammetry, and what to avoid when using them. We'll cover the different types of overlaps, why they're used, and also explain what happens when overlaps are too large, and how to fix that. Before that, if you're just starting out, check out our other beginner video, Basics of Photogrammetry. The link is in the I button and in the description. Stick around till the end and we'll share some common exceptions to the rule that every drone mapper should know. What is imagery overlap? First, let's clarify what overlap means. Overlap is when multiple aerial images capture the same area of ground. These overlapping images allow software to create accurate 3D models, elevation maps, and orthomosaics. Photogrammetry uses this shared visual data to calculate depth, just like how our eyes perceive 3D shapes. Types of overlap in photogrammetry. 1. Forward overlap, also called end lap or longitudinal overlap. Forward overlap is the shared area between consecutive photos along the same flight line. The typical forward overlap is 70% to 80%. Why it's important? It ensures that every part of the terrain is captured at least twice, allowing software to generate stereo pairs for elevation modeling. 2. Side overlap, also called side lap or lateral overlap. Side overlap is the area shared between adjacent flight lines. The typical side overlap is 30% to 40%. This ensures smooth transitions between flight paths and prevents gaps in the final map. 3. Triple overlap, also called three-way overlap or supra-overlap. When a single point appears in 3 or more images, that's triple overlap, useful in hilly terrain or areas with vertical structures. This helps improve accuracy and reduces errors caused by shadows or sudden elevation changes. Problems with too much overlap. Now here's a twist. More overlap isn't always better. Excessive overlap, like above 85% forward or 60% side, can lead to a few issues. More data could lead to more noise. Slower processing times increase data storage, higher battery usage for drones. And in some cases, degraded software performance due to redundant information. Drone mapping software may struggle with unnecessary data, causing alignment errors or failed models. Solutions to overlap issues. So, how do you get the overlap just right? Stick to tested standards. Use 75% forward and 35% side overlap for general flat terrain. Use automated flight software. Tools like DJI GS Pro or Drone Deploy automatically optimize overlap settings. Adjust for wind or terrain. Add a buffer if flying in high winds or over complex terrain, but avoid going overboard. Exceptions to the overlap rule. Sometimes you'll need to break the rules, and that's okay. Here are some exceptions where you might need more than usual overlap. Dense forests or tree canopy, tall buildings or urban canyons, high relief terrain, like mountains or valleys, oblique imagery capture, where the angle makes forward overlap more critical. In such cases, going for 85% forward and 60% side may be necessary. Just be prepared for longer processing and heavier files. Why overlap really matters. Whether you're mapping for agriculture, construction, or land development, proper overlap ensures accurate, measurable, and reliable results. It's a balance. Not too little that you miss details, and not too much that it overwhelms your system. Conclusion and call to action. To sum it up, we covered the 3 main types of overlap, their ideal percentages, the risks of too much overlap, and when it's okay to go beyond the norms. Did this video help you understand overlaps in photogrammetry a little better? Leave us a comment. We'd love to hear how you apply this in your projects. Hit like, subscribe, and share this video with anyone diving into drone mapping or GIS. Thanks for watching, and keep mapping smart.